Hello students, welcome to AIMS India online classes. This is a chemistry session. Here we are discussing about types of chemical reaction chapter. In this session, let us say about what are chemical reactions. Okay. The transformation of chemical substances into another chemical substances is known as chemical change or chemical reaction. That means conversion of a chemical substance into a new form is called chemical change, which is also called as chemical reaction, because there the chemical composition of that substance will be changed when it converts into new substance. That is, it is also called as chemical reaction. For example, rusting of iron, setting of milk into curd, digestion of food, respiration, etc. In these all, if you observe, initially there will be one substance, but after the change, there will be formation of a new substance, isn't it? If you see the first one itself, rusting of iron. What happens in case of rusting of iron? Iron, when it is kept in the open place in the presence of atmospheric air, this iron reacts with atmospheric oxygen in the presence of moisture, and it forms iron oxide, a new substance. That iron oxide we are calling as rust. So we can say this rusting of iron is a chemical change or a chemical reaction, because certain chemical substances are combining here and finally they are forming certain new substances. This overall process is considered as chemical reaction. In the same way, settling of milk into curd, digestion of food, respiration, photosynthesis, these all will come under chemical reactions. Okay. In chemical reaction, new substance is formed, which is completely different in properties from the original substances taken. So, in a chemical reaction, chemical change takes place. That is why we say it also known as chemical change, because here initially taken substance will be converted into new substance. A new chemical substance is formed in this change. And one more point to be observed here is the properties of the new substance formed will be entirely different from the substances initially taken for this change. Okay, that is why it is called chemical change or chemical reaction. Let us consider two processes. One it is dissolution of sugar into water, and the other change is cooking of food. If you observe these two processes, in the first process, that is in the dissolution of sugar into water, the process of the properties of both sugar and water are present in the solution and no new chemical compound is formed. So it is considered as a physical change. What happens when you dissolve sugar into water? It disappears. Means the molecules of sugar will take the places which are existing in between the water molecules. But we have to understand one point here, it is the properties of sugar and water will be remained same. They won't change their properties, and even their chemical formulae or their chemical composition also will be remained same, and there is no formation of any new substance, only they dissolve one into another, just they are mixing. It is a physical process, and even they can be separated by using certain physical techniques, and hence the resultant solution formed here, it is a physical mixture, and this process of mixing sugar into water is a physical change. It comes under physical change. On the other hand, if you see the second process, that is cooking of food. In this process, cooking of food, the ingredients lose their nature and they form a new substance with different properties. So, different properties formed. So, this is called a chemical change, isn't it? If you say, for example, rice. if we take raw rice, if you start cooking that, then the molecules present in that raw rice will be changed. After cooking once, the formula or the composition of that substance will be changed. And even we cannot get back that raw rice from that cooked rice. Isn't it? Not only the rice, even other food items also. Once they are cooked, from those substances formed after cooking, from those we cannot get back the original substances taken in the raw form. Isn't it? That is why we say this cooking process as a chemical change. Okay, dissolution is a physical change, whereas cooking is a chemical change, because in the dissolution process the mixed components can be separated by physical methods. They can be separated simply. But whereas in this chemical process like cooking, the original substances taken cannot be retained back, cannot be obtained back from the chemical substances obtained. And even in the dissolution process, no new substance is formed. Whereas in the cooking process, new chemical substances are formed, or the chemical composition of the substance is changed, which cannot be reversed. Hence, this is a chemical change, whereas the first one is a physical change. Okay, the chemical changes are outcome of chemical reactions. So we are telling chemical changes in which new substance is formed. So this chemical change is actually the outcome of a chemical reaction. To occur a chemical change, there occurs a chemical reaction within. So the chemical reaction can be defined as the change of one or more substances into another substances having different chemical composition and properties. Okay, so what happens that in a chemical change, certain chemical reaction occurs. Because of that chemical reactions only, new substances will be formed in the chemical changes. So we can say chemical reaction can be defined as the change of one or more substances into another substances having different chemical compositions and even properties also. For example, if you see here, hydrogen combining with chlorine to form hydrogen chloride. So what's happening here? Initially, two chemicals are taken. Hydrogen is one of the gases, and even chlorine is also one of the gases. These two chemical substances, they are reacting each other. Combining in the sense they are reacting each other, and they have formed a new substance, hydrogen chloride. And here the properties or the chemical properties of this hydrogen chloride will be entirely different from the properties of hydrogen and chlorine. So we can say it is a chemical change, and here chemical reaction is taken place between the hydrogen and chlorine, and they formed a new chemical substance, hydrogen chloride. Okay, next let us see what are chemical reactants and products. First of all, the chemical substances which take part in a chemical reaction are called as reactants. Okay, once we say chemical changes are taking place, means one or more substances they are changing into new substances. They are changing their composition. There, the substances initially taken the change. The substances which are taking part in the change are called as the reactants. In the same way, the new substances formed in that change, the new substances formed after a chemical reaction are called as products. Okay, the chemical substances formed in a chemical change are said to be products. For example, if you see this reaction between ammonia and hydrochloric acid and resulting in the formation of ammonium chloride. In this reaction, two substances they are participating in the reaction. They are combining chemically. Now, these two substances which are taking part in the chemical reaction are called as reactants. So after the reaction, they are forming a new chemical substance, that is ammonium chloride. NH4Cl is called ammonium chloride. A white dense fumes like it forms there. When ammonia gas and hydrochloric acid gas, if they combine, they form a white dense fumes of ammonium chloride. But if they are taken in the aqueous form means solution with water, they form a solution of ammonium chloride. Here, the ammonium chloride formed is said to be a product because it is formed as a new substance from this change of ammonia and hydrochloric acid. So, the chemical substance which is formed in this reaction is said to be product. If you see another reaction here between carbon and oxygen, when carbon and oxygen they combine, they form carbon dioxide gas. So here the chemical substances participating in the reaction, carbon and oxygen, these two are said to be reactants. And after the reaction of these two, this substance is formed, that is carbon dioxide. So carbon dioxide is said to be product in this reaction. The same chemical change or chemical reaction can be represented with this equation by using symbols and formulae also. This is called chemical equation, which is representing a chemical reaction with the symbols and formulae of the chemical substances participating in that and being formed in that. Okay. Okay. Now let us see the characteristics of these chemical reactions. Some of the important characteristics of chemical reactions are as follows here. One of them is a change of state. For example, if you see hydrogen gas and oxygen gas, if they combine chemically, they form water. We know here hydrogen and oxygen are gaseous substances. When they react each other, they are forming water. So here the formed water is in the liquid state. So the chemical substances participating in the reaction are said to be reactants. So here in this change, the reactants are in the gaseous state. But once the chemical substance formed is said to be product. So here the product is water. But water we know as it is a liquid substance. So in chemical changes, physical state of the components also may vary. Initially, the reactants may be one physical state. They may form products with different physical states. Okay. In this way, two gases they combine to form a liquid. What is happening in this change? Physical state of the substances is being changed. Of course, it may not be happened in all the cases. In chemical reactions, physical states of the components may also change. Another characteristic is evolution of gases. In some chemical changes, there will be evolution of certain gases. Let us see an example. Evolution when sodium reacts with water, bubbles of hydrogen gas is seen. So what happens? When a piece of sodium is dropped into water, we know sodium is a highly reactive metal. It reacts with water immediately and forms a sodium hydroxide and hydrogen gas. This bubbles out like fume. So in certain chemical reactions, there may be evolution of gases. Okay, but here it cannot be done in the laboratory in our own because it is some explosive reaction. See here, fire is coming because sodium is highly reactive metal. It should be always stored under kerosene. Whenever it is needed, it will be taken out from the kerosene. A small piece of that will be taken for usage and the remaining part will be stored under kerosene again. So if you drop this small piece of sodium into water, immediately that reacts with the water vigorously like this with the evolution of heat and forms sodium hydroxide and hydrogen gas. So in this reaction, hydrogen gas is liberated. So in certain chemical reactions, the evolution of gases will be used for the identification of chemical change occurring there. Okay, it is one of the characteristics of the chemical changes. Another one is change in color. Yes, some chemical changes can be identified by change in the color of the components. For example, during rusting, the iron particles undergo change in color, isn't it? Iron actually, if it is taken pure iron, newly formed iron, it will be light greenish blue, gray color we can say. But if it is kept in the open air for few days, we can observe on these iron particles brownish layer will be formed. That brownish layer is because of the formation of iron oxide that we say as rust. So we can observe certain chemical changes because of change in the color. We have also observed that silver gets tarnished when kept for a long time in the open air. In this, the metallic silver reacts with the hydrogen sulfide present in the atmosphere or sulfur present in the air and gets tarnished by the formation of silver sulfide. Have you seen silver articles? They'll be very shiny and bright white color when they're bought. But after a few days, if they are kept in the open air for a few days, they form like dark color layer will be formed on those. The dark color layer is because of the formation of silver sulfide. Because the silver slowly reacts with the hydrogen sulfide particles present in the air and forms hydrogen sulfide, so that the silver particles will be tarnished. They lose their shining color. They'll become dull. So in these changes, rusting of iron and tarnishing of silver particles, what we observed by the chemical change, there is change in the color. So the chemical change can be identified here by the change in color. Okay. Next one, change in temperature. Yes, certain chemical changes can be identified by the change in temperature also. For example, when water is added to quicklime, the mixture becomes hot due to the evolution of heat energy. This kind of chemical changes in which energy is released out while forming products are called as exothermic reactions. So one of the examples is here dissolution of quicklime into water. If quicklime is dissolved into water, then it forms a calcium hydroxide. At the same time, if we touch the beaker in which calcium oxide is added to water, we feel warm because heat energy is evolved in this reaction. Initially water it might be cool, but by the addition of calcium oxide, that container becomes warm if you touch it. That is because of the evolution of heat energy by the reaction of calcium oxide with water. So this kind of reactions in which heat energy is liberated by the formation of products are called exothermic reactions. So in such kind of reactions, change occurring, a chemical change occurring can be identified by the evolution of heat energy. Okay, and in some other chemical changes, we can identify those by certain order. New order will be observed. For example, due to chemical reaction, food gets spoiled and smell really bad, isn't it? Certain fruits, if they are left for few days, slowly they start rotting and they release certain bad smell, isn't it? Even this bread also, if it is left for few days, it starts creating fungi in it and it will be spoiled and it releases certain bad smell and bad gases, isn't it? So by that also we can identify a certain chemical reaction is happened there. So the food will be spoiled. So this also comes under chemical change. So in this kind of chemical changes, happening of chemical change is identified by the order change. Okay. And in certain chemical reactions, there will be the formation of precipitate. Some chemical reactions are characterized by the formation of precipitate. Here, a precipitate is a solid product which separates from the solution during a chemical reaction. So precipitate means a solid substance. Initially, the chemicals taken will be in the aqueous form. When those two chemical substances are mixed, they form a new solid substance which is insoluble into that water. That insoluble solid substance formed is called as precipitate. So by the formation of precipitate also, certain chemical reactions can be recognized. For example, the chemical reaction between potassium iodide and lead nitrate is characterized by the formation of an yellow precipitate of lead iodide. See here, initially potassium iodide is a aqueous solution. Potassium iodide crystals will dissolve into water and they form an aqueous solution. Even lead nitrate also is forming an aqueous solution. But when these two are mixed, immediately they form lead iodide and potassium nitrate. Out of these two, lead iodide formed is insoluble solid substance, results in the formation of an yellow colored precipitate solid substance which is insoluble into water. So by the formation of this yellow colored insoluble solid substance, we can identify as chemical reaction is occurring between these two substances. And this insoluble solid substance formed here is called precipitate. Okay, in this way, certain chemical changes can be recognized or characterized by the formation of precipitate. Okay, that's about the different kinds of chemical changes. Thank you for watching our video. Please subscribe our YouTube channel AIMS Today for latest updates on recorded videos.